Okay, so part 2 of the SQL lecture. The most important SQL statement is the select statement, because that's what returns data out of the database. Or probably, when I say the most important, it's not necessarily the most important, but it's the one that's probably used more often than any of the others. And this is the general syntax of the select statement, and it's probably not hugely apparent to you necessarily what these mean, although you may be used to reading these you may or may not be used to reading these kinds of statements. Basically, it's telling you all the things that you can do in a select statement. The bits in, so the main statements is you put your select statement, then you can have a list of things to return, which is called the extent, which fields to return, from a list of tables, which tables you're getting the data out of, where condition, which allows you to subset on the basis of some sort of criteria, select data on the basis of some sort of criteria, and we'll go through all these in the further slides. Order by, sorting. Group by is to do with grouping records by common values to summarize information. Having will subset the results of a group by. Anyway, we'll get into all these in due course. But this is the general style syntax of the select statement. The parts that are in square brackets are optional clauses. Okay, so you have to have return at least one field or value extracted from a field from the select statement. You could do more than one field, etc., etc. Right, so we'll work through the select statement really simply. And of course, most of you, I would expect, pretty much on top of this, so I'll power through this. So we know select star.table will return all data from a particular table. So here, the example, select star from city simply returns all the rows out of our city table. That's about the simplest select statement you can possibly do. We can return individual fields rather than using star and returning all fields. If we just want to return some of the fields, we can use provide a comma-separated list of fields. And we can use the as word to rename fields, to provide them with what's called an alias. So here, instead of the field name in the city table is name, but we decide we want the title of our column to be, in fact, city. So we can rename the city field, name field as city, and in our output, city there. It's been given an alias. Very useful for giving columns sensible names. Whenever you output data from a query, use a query to export data, it's always a good idea to name the fields sensibly, as the fields in the database may be given a shorthand, they may be given some sort of shorthand code, which may not be very understandable from the person actually looking at the results. As I say, you can return more than one field by just a simple comma-separated list. Here we're doing the name and the district fields. So that's fields that you're returning. The extent option, which comes before the list of fields, is with an optional parameter, and it affects how the data is returned, what rows are returned by the query. The default, which you don't need to add in, is the all, which just means all records are returned as expected given the rest of the query. The distinct keyword is quite often used. It's a really useful one. And what that does is it takes any duplicate tuples out of what's returned and just returns one. If you've got duplicate tuples, it'll just return one of those duplicates. So every record will be unique if you put in the distinct keyword. Some queries will never return duplicate rows, some will. The limit keyword or extent can be used to just list the first so many records that are returned. So they'll list the top 5, the top 10, the top 15, the top 20. Okay, all is the default, so you don't need to put anything. So if I do select country code from city, that's the code, the ISO code, the International Standards Organization code that identifies the country. So if I select country code from the city table, I've got 4 AFGs followed by a load of NLDs plus whatever else. So what this is telling me is I have 3 cities with the country with the country code AFG, which is Afghanistan. These ones are in the Netherlands. Okay, so we've got duplicate rows. We're returning 4 rows that have the same value. If I stick the distinct keyword in, all those duplicates are removed, and in this case, I get BLZ. They're being listed BLZ, BGD, ITA, OMM. Now, it's interesting to note, if we go back to the previous slide, we've got AFG, NLD. You see the order of the rows that are being returned is different depending on whether we've got the distinct keyword in or not. Remembering one of the principles of the relational model is that the ordering of rows doesn't matter. If we were to order them alphabetically, then we would have got, one version of AFG somewhere in our alphabetical list. Okay, so bear that in mind. The AFG hasn't vanished with the distinct keyword; it's just simply further down in our list there. Limit, very simply, there's the top 5 from our limit. We can limit by 5. Note that limit goes at the end of the select statement. It's not part up there at the beginning of it. So that's select. It's that simple. Where clause. Oh, I should actually mention while we're back up at select is that you can also do calculations. It doesn't have to just be a field here. You can do functions on fields, calculations on fields, and things like that. Okay, where clause. Where clauses restrict the number of rows returned on the basis of some sort of criteria. So there are a whole number of operators that can be applied, or conditional operators. Things like, that shouldn't be there, but equals, greater than, less than, greater than or equals, your standard mathematical symbols. Also, we've got other things that can be included in the where clause, things like and, not, and or, logical operators on that you can use, between a maximum and a minimum value, likes, is nulls. There's a whole variety of these operations. So we'll see some of these. So equals and greater than and less than work with both numeric data and text data. So you can use the same operations on text. And text, the ordering of the letters, I believe, is sort of lowercase a to z, followed by uppercase a to z. There's an ordering of letters. So if you do a greater than operation on a string, say greater than s, it'll give you ones that start with the letter s or T, U, V, W, etc. Anyway, so simple. Let's start simple. Equals. We can use equals on a text string. So if we want the cities in Scotland, we can just do select name and district from city, where district equals Scotland. So Scotland is not a country. Well, it depends on who you talk to and what you would believe about constitutional law and things like that. But in this database, Scotland is a district. It is not a country. So we can put the criteria where the district equals Scotland, and we just get the 4 cities in Scotland returned. Similarly, if we don't want Scotland and we want everywhere else, we can use the not equals operator to get everywhere else but Scotland, every other city, all the cities that aren't in Scotland that are in our database. Like provides a sort of wildcard match. I'm sure you've come across these before. So if I want all the cities in districts that start with the letters S and C, I can write this. This is in Postgres syntax, by the way. The syntax, so you're probably more used to seeing a star. In fact, we've just seen select star from to return all the rows. Star is often used as the wildcard, what's called the wildcard character. But in Postgres, in a string, they use the percentage sign. Okay, so we want all cities from the districts which start with the letters SC. There we are, we've got our Scottish cities, but we've also got Schaan, which I guess is in the Netherlands, but that's just a guess. Kiel in Schwerin, Holstein, somebody in Germany, etc., etc. We can put wildcards either side. So in this case, we can have more than one wildcard, so we want any district with an S and a C somewhere in it. Okay? So here we've got Scotland. It happens to be at the beginning. Nova Scotia has it in the middle. Schaan has it in the beginning, and Holstein has it at the beginning as well. We can also do, so this is an example of, we stuck it in the middle, so we want all the districts that start with an S and end with a D in this case. So Scotland obviously starts with an S and ends in a D. Sindh province in India also starts with an S and ends in a D. So that's equals, mostly on text, but you can imagine you can do it on numbers as well. Greater than or equals, here on a numeric column called on population. So I want the cities with a population greater than 1 million. Very straightforward. Population greater than. We can combine, we can do less than, equals, a greater than or equals to. I'm not going to go into all the combinations. We can combine conditional clauses together with conditional operators. So here we want the populations, cities in Scotland with the populations greater than 250,000, and it returns to the two main cities, Glasgow and Edinburgh. I always think Glasgow has a much bigger population than that. It always surprises me that it's that low. I thought it was up to about 2 million. But of course it depends on what is Glasgow, your definition of what Glasgow is. There is the city of Glasgow, and then there is the metropolitan region of Glasgow, just like, I'm never quite sure, are we in Greater London here? Yes, we are. But if we go a mile up the road, we're out in Surrey, yet it's a continuous urban area. So where does London stop? That's always a sort of ontological question. What is the limit of London? Is it the boundary of the boroughs? Is it the boundary of the urban area? Is it within the M25 or something like that? Okay, so Glasgow's only 619,000. So that's, we use and if both conditions have to be met. We can use or if we only want one of the conditions to be met, either of the conditions to be met. So here we're getting cities that are in Scotland or have a population greater than 250,000. So here we've got the population of, in this case Aberdeen, which is 215,000. It's probably not a good selection because I should have one from Scotland that has a population greater than 250,000, but I've seemed to have not selected the best rows to show, but you know the principle. They're either in Scotland or they have a population of 250,000 or greater. This is like maths. We can use parentheses to specify the ordering of queries and functions. So here we are looking for cities that are either in Scotland or in England, but they must have a population of greater than 250,000. So this is English and Scottish cities with populations greater than 200,000. Because we do the OR function first, then we apply the AND function afterwards, because it's outside the parentheses. Not provides the negation, the opposite of what the statement that you'll want. Well, this was perhaps not the brainiest example to use, but then I'm not the brainiest of person. So here we've got an example where we're using not, but we're also using a not equals operator, so we're actually defining a double negative here, which is silly. But then quite a lot of the examples that I'll be giving you are actually kind of toy examples, silly examples. They're just demonstrating the principle, not they're actually sensible ways to write these queries. So here we're getting the name and the district again from the city, where the district isn't equal to Scotland, so everywhere that isn't Scotland, but we're negating that so it becomes Scotland. Yeah? Take a double negative. Not the brainiest of examples. Nulls, remember nulls? Nulls are those special values that where we don't know of the value. So for example here, the life expectancy figures for the country, we can see that Svalbard and Jan Mayen, we have no expected life expectancy figures. It's not that they don't have any expected life, but they have no life expectancy figures for whatever reason. It's not a country, I mean that's as a country, but Svalbard I didn't think was a country, because Svalbard is part of it's a district of Norway, yeah. So why is it even here as a country? Does it merit being a country? What is a country? Okay, so we want to exclude all the ones, or let's find out, no, let's get the ones that have null values so that we can understand how many null values in our data. So we can just use the is null in the where clause to get the values, the rows with null values. Look at these places where the null values are, the Falkland Islands, Svalbard, Christmas Island. They're mostly very small, wild and windy, unoccupied, or not unoccupied, minimally occupied places, let us say, around the globe. And for whatever reason, figures have not been collected or are not available for these various locations. If I want to get just the ones with proper values in, with values in, then you can use the is not null, and that will return the ones with valid values. Afghanistan, Netherlands, Angor. Okay, so we've returned some sort of subset, we've written some sort of where clause, but we want to order the results, sort them in some formal fashion, where we can use an order by clause to specify ordering, sorting of the results. So here we're sorting by the population field in a descending order. So here Mumbai is the largest city in our database with a population of 10.5 million, followed by Seoul, followed by Sao Paulo in Brazil, Shanghai, etc., etc. If we want to do it ascending, we just use the ascending ASC instead of DSC for descending. And in this case, I've just returned the ones with populations greater than 9 million. Karachi, Jakarta, Shanghai. And as you can see, these are increasing in population as we go down our list. We can order by more than one column. So here we're ordering by district, descending. Now so Wales, so descending in alphabetical is from Z to A rather than A to Z. So Wales, Scotland, so we're doing only the Great British, we're only doing the districts in Great Britain, so Wales, Scotland, Northern Ireland. Oh, we've got Jersey there. England, we're ordering by the district, first Wales, then by the cities within the district. Very straightforward. So we're doing that one descending, this one ascending. Cardiff, Newport, Swansea, ascending. Then we ascend through Scotland, ascend through all the other groups. There we go, that's sorting. Aggregation. Aggregation is about summarizing numeric data. It's mostly numeric data. You can summarize, so you can count other non-numeric fields, but the rest of them only apply to numeric fields. Now, the aggregation statistics or metrics that are available in a relational database are very limited compared with those that are available in a statistics package. So you can see that we have the count, the number of records, the sum, total, add the sum of all the numbers in your returned the maximum value, the minimum value, or the average value, the mean value. Sum of all the values divided by the number of values. But there is no aggregation statistic, for example, for the median value. The median, if you know what the median is, line all our numbers up in a row, it's the middle number in our row of values, the median value. So if I wanted the median value, I couldn't get it as a standard database function. I actually did want the median for an application I was developing. I did find SQL code online for calculating the median, but it took so slow that it wasn't actually practical to implement. So what databases can do some statistics, aggregate data and calculate statistics for you. They are not a statistics package and shouldn't be used. You shouldn't attempt to use them as a statistics package. If you need fancy statistics, remember there are functions. Functions can call programs written in other languages. So if I now wanted the median, I would probably write a function that went out and called the R statistics program that did the calculations and then pumped the result back into the thing. Right, I'm going to have to complain about this system restart because this is just annoying. Anyway, so limited, only very limited stats in relational databases. Come on, system. I'm wondering whether it's set to do this on Wednesday afternoons because they believe nobody's in the labs on Wednesday afternoons, so they can get away with it. In which case we'll need to, and then it's gone off my laptop thing. Right, we're back. Okay. Very simple. Select, count, star, we're counting all the rows, and the sum of the population field, the maximum of the population field, the minimum of the population, and the average of the population from the cities. So that's a simple one query that's doing all those different functions. We only get one row returned because it is summary statistics on all the cities in the database. Yep. So there are 4,079 cities in the database. The total population in the database is whatever that number is, 1.4 billion. The maximum population size is 500 something or other, but we know that that is a 10,000 in fact, but it's right justified in that column, so that's why it looks like 500,000. Okay, principle. Everyone happy with that? Yep, good. Group by. So what this does is it takes a value in a field and it groups all the records that share that value and calculates some kind of statistic on each of those groups. So if I want to know how many cities are in each country, how many cities are in each country? So I can select the country code, which gives me the code for the country. Okay, I could have got a join and got the country name off the country table, but that just makes it more complicated. So we'll just work with the codes at the moment. So we've got, for each country code, give me the count of the rows from city. So what it does is it gets the city table, basically orders them, sorts them by the country code, and then counts how many rows share the country code. So that there are 2 cities in BLZ. Anybody got any ideas which country? Sorry? Belize. Good. Well, yeah, Italy has 58 cities in it. Yes, Belize sounds a good bet. Okay. Group by. You can group by more than one column if you want. So here we've got the country code, the district, and the count from cities. So what we're doing is counting how many cities are in each district in each country. Okay? So we return the country code, the city code, and the number of cities, the count of records. Well, oh, sorry, we're doing country code from city. Okay, so city, we're doing country. Oh, city, how many cities are in each district? I was just suddenly wondering why there were cities and cities. So in the Kabul area, district of Afghanistan, there is one city, but in the Benguelia region of, I'm guessing that's Angola, are 2 cities. Having, so we've done a group by, and we've got some sort of statistics on the group by clause. Having is effectively a select action on a group by clause. So it subsets the record results of a group by function. So if we want countries with more than 40 cities ordered by the number of cities, I can go to the country code, the district. Oh no, this is districts with more than one code. Sorry, this is districts rather than cities. Countries, no, yeah, this is districts with more than 40 cities. Sorry, this is districts with more than 40 cities. So it's countries with districts with more than 40 cities. So we can return the country code, the district, and the count of the number of records from city. We group by the country code and the district. And then we've got our having function that says only return countries and districts with a count of the number of cities is greater than 40. Yep. And then we're ordering by number descending. So England has the most numbers of cities in this database, 71. Sao Paulo then, the Sao Paulo region then has 69 cities. Hooray, joining data. So that's your basic select clause. We're now going back to the where clause and to look at how we join data across tables. So some of you will have already done this, I'm sure, but here we go. Okay, joins. Join allows us to connect data in different tables through shared field values. Remember your primary key, foreign key combinations. So there are 4 types of join: inner, left, right, and outer, that do slightly different things. So an inner join, as it says in the table there, returns tuples with a matching values in both tables. So it's effectively an AND clause between the 2 tables. Left join will return all tuples in table A and only matching ones from B. Right does the opposite, only matching tuples from A and all the tuples from B. So these are just the inverse of each other. And finally, an outer join returns all tuples from A and B and all unmatched tuples from both. Now that's probably just word spaghetti in your head. So let's have a diagram or 2 to show these. Okay, so this is a diagram that shows all combination permutations of intersections between 2 tables. So your 2 tables are A and B. These are Venn diagrams, obviously, 2 simple Venn diagrams. So we've got 2 tables, A and B, each of which has a number of records in. We're joining them on a shared column that's shared between those 2 tables, a primary key in one, foreign key in the other. Okay, so an inner join is this. We want the tuples that are in A that also match, where the joining fields match those in B. So we get the intersection of those 2 tables, where the table A and table B both have rows with the same values in them. Okay, the left join is this. So we get all the records from A and records matching records from B. That's the right join, and it's just the inverse of that relationship. Finally, we have the full outer join down here, which is all the records from A, whether they match or not, and all the records from B, whether they match. Sorry, all the records from A that match with B, plus all the records from A that don't match, plus all the records from B that don't match. These other ones that you see about are, as you can see, you can get to these portions or these portions of the Venn diagram when you include null values or exclude null values from a calculation. Don't worry about that. So let's see an inner join in action. So here we are. We want to know we're getting the city name from the city table, the country name from the country table, and the continent that the country is in from the country table. We're going to do a simple inner join on that so that we can match on the country code. So the country code in city, we know is that 3-letter code that identifies which country it is. And in the country table, it's the code field that contains that 3-value code. So there's one code for each country. Okay, so we want to match cities and their codes to countries and their codes. So that's our function. So that's our select statement. The join in this case is simply done in the where clause by city.countrycode equals country.code. And that allows us to join up the things. So Kabul, Afghanistan, Asia. As we can say this, the country.name is coming from the country table, the continent's coming from the country table, the city is coming from the city table. And we can just write an inner join like that. That, however, is kind of your beginner's syntax. I use it all the time. It's dead handy. And because inner joins are what you do more often than anything else, they're the most common join by far that has to be undertaken. I would say I probably do 99 inner joins for every other type of join that I've ever done in my life, if you care for such. However, this is probably what we might call the better syntax. This is the syntax that you have to use for the other types of joins. So I've actually started trying to change my behavior and stopped writing just the simple equal syntax and trying to write this syntax whenever I want to do a join, just to burn this syntax into my brain so I never forget. So in this case, this is exactly the same query, but instead of having the where clause and the join specified in the where clause, we've got it in the from clause, and we're joining the city, and we're doing an inner join onto the country table. Then we have the on word to specify which fields we're doing the match on. And in this case, the city country code is being mapped to the country code. So I would advise you using that syntax over the other syntax, but they both work perfectly well and are perfectly good. So there's two syntaxes for an inner join. That's the only join type where there is an alternative syntax for. Okay, so not all countries have a capital city. Antarctica has no city. So this is an integer. This is the ID number of the city, a city in the city table. So it's telling us, and each country can obviously, well, depends what you define as a capital city, just like what you define as a country. So some countries have more than one capital city. They maybe have a government capital and an administrative capital. They may have a legislative capital and an administrative capital. Technically, I think the government capital is the official capital of a country. So, for example, Antarctica has no capital. Is Antarctica a country? This is a debate I have with my 7-year-old son. He's always asking these kinds of questions. United States, minor outlying islands, southern French territories. It's the odds and sods again, just like we had with life expectancies. But not all countries have capital cities. Okay, so if I want to get the country, the capital name for each country, and I want to include all the countries, even the ones that don't have designated capitals in the return, in the query or in the table, then I want to use a left join, or I can use a left join. I could do it on a right join as well, but I'm doing it on a left join. So I've got country name as country, city.name as capital, country, capital. From the country table, doing a left join onto city, which means I'm going to keep all the records, the rows, whether they match or not in country, but not from city, only the matching ones from city, countries on the left. Then we're going to match on the city ID equals the country capital number. And in this case, I've just ordered them by the capital so that we can see the ones with null values in it. And as you can see, I'm now getting the capital that matches the city or the city ID, the name of the city, where the city ID matches the ID, the capital ID in the country table. But as you can see, we're also returning these rows from country that have null values for city as well. I don't have this data set that I've been using as examples, doesn't have a good example. It's not a good data set. I couldn't think of a good example as a full outer join or indeed a right join, except swapping the city and country tables in the previous query, and then we could have done a right join and got the same result. But this is a little schematic, parts and products, that sort of shows you the example of the output. So here, the left join between these two tables, we have oil here, we have a product number, but there's no equivalent product number in products. So in a left join, we've got oil here, and we get a null value in price because we don't have a record in price. If we go over to the right-hand side, in this case, we're listing products, or parts, sorry, we're listing parts, and we've got a part that has a price, 370 part 505, that doesn't list in this parts table. But because we've done a right outer join, that's the right-hand table, we get unmatched records return. The full outer join is just these two put together, so we've now got all matching records, the unmatched on the left and the unmatched on the right. That's your full outer join. Getting there. Tuples, so that is combining horizontally combining the records in different tables. Yep. So you've got tables with different fields, but generally they share one field, and you combine the tables horizontally on the basis of that shared values in that field. This is about appending things vertically. So you've got two tables with the same, as we call it, schema, so the same database fields, and we're saying we're appending one onto the other, putting them together into one single table. So we're talking about tables with exactly the same fields, same number of fields and the same data types in their fields. And we've got three commands. We've got union, except, and intersect. And these are illustrated again with these little Venn diagrams. So a union will return all the tuples in A and B, excluding duplicates. Union all will do all tuples in both tables. Sorry, a union will do all tuples in A and B, but exclude duplicates. Union all will do all tuples in A and B, but include duplicates, except does tuples in A that are not in B, and intersect does tuples that are both in B and A. Yet again, nothing like an example. Okay, this is silly toy examples. There is no way I write a query to get this result in this way, but it's the principle that matters. Okay, so we've got two queries that return the tables with the same fields. So here I've got select. My first query is select name from city where name like A, capital A %. So that's returning all the cities that begin with the capital A. Then I've got a second query, select name from city where name like star %A. So that's all the cities that end in A. So I've got two tables, subtables from city, and then I'm putting those back together again using the union command. And in this case, that's going to take all the rows from here and all the rows from here, put them together, and then remove any duplicate rows. So we should, so in this table, we should return all cities that start with an A, all cities that finish with an A, and one record for cities that start with a capital A and end with a little a. Yep. And if we look here, Americana starts with a capital A, ends with a little 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 a, starts and ends with a little a. We should have, because it's the union command, we should have no duplicates. If we use the union all command, rather than the union command, okay, this query is a bit more complex. And why I did it like this, why did I do it like that? Because I can't put an order. All right. So what this is the same query. Here's the subquery. Here's the query, starting with A, capital A, ending with little a. Then because I want to order the final results after having done the union all, I then have to wrap that in a subquery that I can do the ordering on. That's why it's more complicated. It's more complicated because I wanted to do the ordering, because then I can show you the repetition of data as it's returned. So in this case, we've got, you can see ABBA, wherever that is, no idea, ABBA, is returned twice, because it's returned once from the select clause that says start with a capital A, once from the select clause that says ends in an A, and because we're using union all, both sets of tuples from both tables are included, duplicates are not excluded. So we have one version from that query, so one version from that query, and that's why we've got two records for that city in there. Intersect. Oh, well, we know what that does. So that should give us just cities that start with a capital A and end with a capital A. Okay, so cities, capital A's, lower A's, it's just doing the ones that are in both tables returned by those two select queries. Except does, in this case, the names of cities that start with A, so the first query is names, but do not end with A. So we should find none in our return that end in A. But what's that? Well, that doesn't end in A, that ends in a parenthesis. So that one doesn't count. So it's been correctly returned. So watch that. Error, things like that. Your data may not be formatted exactly how you expect it to be formatted. Right, functions, there are lots, Postgres and other relational databases, as I've mentioned, supported lots of different functions. So here, I'm not going to even bother to run through all of them, we'll just give you a couple of here. So the char length function returns the number of characters in a text string. So here, I'm applying the character length function to the name field of city, and then I've got a clause, a where clause that says only return rows where there's more than 5 characters in the city name. So basically, it's Kandahar has 8 characters, Mazir Sharif has 14 characters, Amsterdam has 9. Straightforward thing. How many characters are there in a text string? And we can do there's all sorts of other characters. So if we want the first 2 characters in a city name, we can use, or any text field, we can use the left function, followed by a parameter, that 2 up there, which says, give me the first 2 characters from the left end of the string. So this is Kabul. The first 2 letters are KA, Kandahar, QA, etc., etc. So we can get these, extract substrings out of our strings. We can put together information, data in different fields into a single field through a process called concatenation. So that's the double pipe symbol. So the pipe symbol is that kind of long, straight upward line that sometimes has a break in it. And for many people, you have wondered, well, if you've even noticed it on your keyboard, you might have wondered what it was about. Well, it's used in computing quite a bit, actually, to mean concatenation. So I want to select the city name, and then I want to add on to that string, in this case, two characters, a comma followed by a space. Then I'm going to concatenate the region, then I'm going to concatenate another comma and a space, and then the country name. And in this case, I'm going to use the upper function on the country name to make it all uppercase. And so that's one field that I'm returning, and I'm recalling that location from city and country, and then do the join. So I end up with one field returned, one column, which is a combination of the data in those different fields. So Kabul, southern Central Asia, Afghanistan. So you can see that we're outputting, that maybe that is what we want to output into some sort of report or something like that. Okay. Your basic SQL will do the vast majority of what you need to do. However, as your queries become more and more complex, it becomes more and more difficult to do it in a single query without being a superb SQL expert. And one of the ways to write complex queries, both sometimes you need what's called subqueries. Other times it's just easier to write with a subquery than it is to actually write a full proper single query to do what you want to do. So sometimes it's just the fact that this is the easier way to get a solution. So what is a subquery? That is a query embedded in another query, basically. So country language has a field called percentage, which shows what percentage of people in the country speak a particular language. So if I want to know, if I want countries where everybody only speaks one language, no, that's not right, where everybody speaks one language. They may speak more than one language, but everybody speaks one language, or statistically they do. Of course, the reality may not be the same. I could write a query that says select country code from country language where % equals 100, and that would be a very sensible, the most sensible way of writing the query. But I could write that same query as a subquery. Again, totally pointless. You know, it's a totally artificial example. But here, it's just showing you the use of the in clause to specify a subquery. So in here, I'm selecting the name from the country table, from country, where the code, the country code, the code field in country, is returned, is in the results of this select query here that's within these parentheses, which is select country code from country language where % equals 100. So this select query returns me a list of country codes. The in function is then saying, is being used in the where clause to say, does this value match the values returned, or the value returned? You can only ever return one field in a subquery like this. Okay. So again, a bit of an artificial example. You may find it useful sometimes to write subqueries. All right, let's power on just to get to the end quickly. Delete and insert, deleting records, inserting records. Okay, so first of all, I'm going to obliterate Dundee. My wife's from Dundee, but there's nothing to do with choice of city here. But okay, select all from city where name equals Dundee. So we've got one record for Dundee in our database. Okay, I want to delete the records, that Dundee record. I can do just delete from city where name equals Dundee. Query returned successfully, one row affected. That's great. I've deleted my record from the database. Of course, there's no guarantee that there aren't, in fact, there must be other cities in the world called Dundee, just like there are other places called York, other Londons. There's one, there's Ontario, yeah, and I was getting, suddenly had Moscow, which is in some American state. I can never remember which one Moscow is in. It's one of those northern plain states. So a city name is not a unique identifier by any means. So we might have made a mistake if we hadn't done select star from city where name equals Dundee first and found out there was only one Dundee record. We could have deleted half a dozen Dundees in other countries that we didn't know were in the database by accident. So always a good look before you leap. Remember everything, there's no undo button on a database. It's instantly done the moment it's done. And if we do the select star from city, wow, what a surprise, there is no Dundee record. If I want to insert that data back in there again, I can use the insert into command, the city, the name of the table that I'm inserting the data into. There is then an optional list of the order of fields which matches the order of values provided on the values argument. So the ID field in the table is the first one in the list. The name is the second one, the country code is the third one, the district is the fourth one. If your values are in the same order that the columns are in the table in the database, then you don't need this. And indeed, this is not required in this statement because these are in the order that they are in the table. And if it works, I get one row inspected. If I want to decide I want to update that record, the population of Dundee is increased, I can do an update command. I can set the population to the new value. I've got my where clause because I want to only update the record in Dundee. Then run a select to make sure it's actually done what you think it's going to do. Sometimes you want to save the results into a new table rather than just have it as an instant result and then it's gone. So the select so select fields into command, a new table name will create a new table from the results extracted from your query. So I'm selecting all records rows into a table called UK cities from the city table where the country equals Great Britain. So I'm making a table just with the records of Great British cities or cities in Great Britain. And there it is. I wonder what that slide was about for a sec. There it is. There's our new UK cities table. Views. Views are saved queries that can be used as a table. So we could create a new permanent table called UK cities. However, we could create a view, which is a saved version of the query that made the cities, and then use that to recreate as the sort of cities table. So I can create a view, UK city view, as, and then the select statement that returns the data that I want. Then when I want to see my UK cities, I do select star from UK city view. So this is a view, not a table. And when that view runs, this is the view, it runs that select query and dynamically creates the table on the fly. So do you want a permanent version of your Great British table, or do you just want a quick view onto it? Depends on what you're trying to do.
That view goes with that.
Sorry?
That view is gone.
No, the view will be saved as a database object. It can be used in queries. It can be used just like a normal table.
Okay. So what's the difference?
This is dynamically, the table, the UK city view is dynamically extracted from the database each time you do something to it. The select into option actually recreates a copy of the data in a new table. So if you then add new cities in the UK, they would not be reflected in the result here, but they would in the view. So yes, depends what you're trying to do. User defines SQL functions, let's leave that. Okay, this is just the format of, just showing that you can also embed these and create your own functions. So rather than do a view, we can do the same thing. We can pass in this case, some text. So what we're doing here, this is defining a function. Don't need to worry about the details of this. This is sort of the very end of it. But the principle is that views, you can't pass in arguments into a view or parameters and things into a view. You can into a function. So here we're creating a function called getPopulation that returns text. Oh, sorry, it's called getPopulation, and it's got one input, one argument that you can put in, which is the text. And a text here is being used to match to the country code. Okay, so so whenever we run this function called getPop, it runs select population from country where code equals this $1. This $1 is the first argument, the only argument passed into it by the user. So to run that, once I've created this function, I can run select getPop, pass in a country code, NLD for Netherlands, and it returns me, in this case, the population of the Netherlands. But I could put in GBR and get the population of Great Britain. So you can pass arguments into functions, but you can't into views. Oh, you can also set users, create new users, grant permissions, select permissions, write permissions, read permissions, etc., on tables and views and every other database object. So that's SQL. Some things to remember about SQL, so a bit of a texty slide. There are for one problem, as we've seen, there could be many solutions. Every solution differs in its efficiency. You need to write queries that return the data required within an acceptable time. Now, if you only run a query once a month, and it takes 4 hours, and you can run it overnight, and nobody cares, that's brilliant. But if it's needed to be run every 20 seconds or something, then you need it to be much, much quicker, probably. So how fast a query needs to run depends on its use. Obviously you could sit there with a timer and time how long a query takes, but the query time is returned as a message, certainly when you're undertaking an SQL query, certainly in pgadmin 3, so you can see how long a query takes. If it's taking too long, what do? Well, you can do things like experiment with the explain command, which provides an explanation as to how the query is being undertaken by the query planner. And then you can get into the world of query optimization, which I'm not going into now. So bear that in mind. There are many solutions to the same query quite often. And as long as your one works, the question is, does it work under the circumstances in which you want to use it? That's the important thing. Okay, here's a quick example of what an explain turns out. We're not going to worry about that. Summary. Okay, relational model, theoretical model, we know that. Theoretical model of what a relational database is and how it operates. SQL is the standard language for interacting with relational databases. Different databases implement the SQL standard at different degrees. And the syntax of SQL in Postgres is pretty close to the standard most of the time. So by learning Postgres, you're almost learning the standard.